Hi everyone, Mr. Neighbor here, and we're talking about energy. We have two main types of energy: potential energy, which is stored energy, and kinetic energy, which is the movement type of energy. So we were calculating gravitational potential energy before, which we calculate by mass times gravity times height. Now we're going to calculate kinetic energy, specifically the movement kind of kinetic energy, the most general kind that we use. So that formula goes as thus: 1/2 mv squared. So let's use that to do a few practice problems. Determine the kinetic energy of a 625 kilogram roller coaster that is moving with a speed of 18.3 meters per second. So kinetic energy equals 1/2 our mass, 625 kilograms, times our speed, 18.3 meters per second. Punch that into a calculator. You'll get out 5,718.75 joules. With sig figs, it will be 5,720 joules. All right. 55 kilogram man jogs at 4 meters per second. Find his kinetic energy. So kinetic energy due to his movement is equal to 1/2 mass, which is 55, times 4 meters per second. So half of 4 would be 2. So just, oops, I forgot to square this. I've also forgot to square it in the last problem. So we'll go back and fix that. But this would be 16. Half of 16 is 8. So 55 times 8. That would be 440 joules. And that would round to 400 joules with sig figs. So let's go back over here. Let's do some corrections. We got to square this. So I just got to retype it. That is no longer my answer. I'll write it in green down here. And then we get out 105,000 joules approximately. That's better. So don't forget that square. Very, very important when calculating kinetic energy. A car that's 300 kilograms has a kinetic energy of 500 joules. Find its speed. So kinetic energy, it has 500. 1/2 times its mass of 300 times the velocity squared. So let's do 1/2 times 300, which is 150. So I'm going to take 150 and divide that over to the other side so I can get out my number over there. That gives me 3.3 repeating. And now to undo the square, I'll have to square root that. So square rooting both sides now. That will give me approximately 1.8257 with sig figs, just 2 meters per second. An object is moving at a speed of 20 meters per second, has a kinetic energy of 10,000 joules. What is the mass of the object then? So kinetic energy is 10,000 joules. Multiply it by 1/2, or that is equal to 1/2 times the mass times velocity squared, meters per second squared. So 20 times 20 would be 400. Half of 400 is 200. So 10,000 divided by 200 should be 50, if I do my math right. So it should be 50. So maybe what that object could be, 75 kilograms is usually like an adult-sized human. So this might be an adolescent in size, like that comparable weight. Not saying an adolescent is flying through the air at 20 meters per second, but something of that weight. So we've been talking about energy and how work relates to energy. They have the same label, so they have to equal in some manner and have the same quantities going around. So we defined in a previous video that work was an energy that's being changed. Maybe it changes from potential to kinetic. Maybe it changes from going 0 meters per second to 20 meters per second. That's a change in kinetic energy. So work had to be done for that to happen. There had to be a force applied over a distance for that to occur. And I just want to show you how these relate. So let's just look at gravitational potential energy. So it's a form of energy and it's going to be changed. So what is gravitational potential energy? It is mass times gravity times height, or the change in y. What is work? It is force applied over a distance. Well, if you think about mass times gravity, gravity is really just an acceleration. So mass times acceleration. We know mass times acceleration to be a force. In this case, it's the force due to gravity. Here, work is the force applied. So notice how both of these equations have a force that is acting over a displacement, and that's why work is happening. For all of the equations that involve energy, this breakdown can be done in a different method maybe, but it always works out that a force is being applied over a distance. That's why we know work is the same thing as energy that is being transferred. So when you do work on the object, you transfer energy to the object. So remember that. So if we have a 1.5 kilogram soccer ball that is held 2 meters above the ground, what is the potential energy of the soccer ball relative to the ground? So let's do this really quick. So the gravitational potential energy is mass times gravity times height. We know the mass is 1.5 kilograms. We know gravity is 10 meters per second squared. And we know that the height is 2 meters. So when we multiply all these together, 1.5 times 10 is 15. 15 times 2 is 30. And with sig figs, it's looking like we're going to be 2. So 30 point and joules exactly. How much work was done to lift the soccer ball into the air? Well, let's just look at two pieces here. So the potential energy due to gravity down here and the potential energy due to gravity up here. What we just calculated was the one up here because we were 2 meters off the ground. So that's 30 joules. Down here, our height is 0. So if this is 0, that means all of this is 0. So the potential energy down here is 0 joules. So work is a change in energy. So how much did the energy change? It changed by 30 joules. So how much work was done on the ball to lift it into the air? 30 joules of work. So work and energy transferred, they are the same thing. Keep that in mind. This is going to relate to the next section. It's a good segue into conservation of energy.